Hey, how's it going? And today we are taking a deep dive into what an interface is and why does it matter and why does anyone care and why. I'm doing this just because it was not clear to me what an interface is, and it was driving me absolutely crazy because I couldn't understand why I would even use it, why is it even being documented what it is, would I ever use one? Well, you might not ever need to actually build one in your verse code, but if and when you do, it'll be nice to know what it is. And second, there are interfaces in the verse language, so having an understanding of what the interface is will hopefully open some doors for you in terms of understanding. The question is an interface. What is it? It is a set of unimplemented methods. Verse defines it as basically a contract for interacting with a class that uses it. But an unimplemented method is a method that doesn't have a body in it. So it has a name, an input, and an output, but no body. It's like a car with no engine almost. It's like, why would you even create something like that? So what does a contract do? This word was throwing me off because it's used a lot. A contract. I think of a contract, I think of business, I think of a meeting of the minds, I think of two people signing a piece of paper, understanding, agreeing to something. Is it really a contract? Who's signing the papers? I didn't sign anything. So anyway, I think of it as not so much a contract, but what does a contract do? Well, a contract ensures compliance. You agree to do something, I agree to do something, and if either you or I don't do it, then we end up in court because you breached the contract. Instead of thinking of an interface as a contract, I think of it as something that ensures compliance. What exactly is the contract? What is the interface insurance compliance with? So they're telling us it's a contract. Contract of what? What's the contract? Well, in verse, the interface only ensures the following things. Of any class implementing the interface, it will, and here are basically the stipulations of the contract, it will implement every method in the interface. It will have the same method names as in the interface. It will have the same inputs or parameters, and it will have the same outputs or return values. So at first, that's quite a few things to agree with. They're pretty general, but that's a lot to agree with. So if the interface has 15 methods in it and you were going to implement it, you would have to have those 15 methods in your class and they'd all have to be implemented. You'd have to write them out, all 15 of them. This really is the main question is why would I ever even use an interface? Well, honestly, interfaces save time, especially the bigger your program gets, the more chaotic and confusing the code can get. So for a lot of people using Verse, they may never even ever need to implement an interface. If you're writing a small program, it would be for something where you've got lots of classes and you've got a set of core functionality that you want those classes to implement. When you know that a class is implementing an interface, then you know right away exactly what methods are available to you. You know what the names are, you know what the required inputs and outputs are. So it saves time ultimately because you've got this standardization going on. And I say, oh, this is implementing such and such interface. I go, okay, I know it's got these four methods built into it. The interfaces drive consistency and reduce confusion. So if you have a big program and are using a lot of classes, interfaces help ensure consistency and ultimately they help reduce errors. So what do I need to know about interfaces in Verse? You cannot create instances of them. Each class that uses an interface must have its own specific implementation of it. In other words, even though the interface specifies the name, the output, and the input, the throughput must be written for each method in your class. A class can implement multiple interfaces, and a class can inherit from one class and also implement an interface. One interface can have multiple implementations. Interfaces do not force a class relationship upon the classes implementing them. And in cases where inheritance isn't going to help you, an interface might. Here is a example that I came up with. Let's say you're writing a program that simulates hiring a gardener. There are three types of gardeners. There's a professional, a student, and an AI robot. And those are the three types of gardeners that you're going to be writing in code. So each one of those, a professional, a student, and a robot, would be three separate classes. Now, for this program, you might consider creating an interface called hire, and in it there are three methods. So basically, you want to know how well was the lawn cut. So let's say you have a requirement that the lawn has to be mowed, it's no higher than 2 inches. And let's say you also want the lawn needs to be mowed twice a month, and that you also expect to be billed monthly. So for those three classes of gardeners, each one of them you would expect for them to have that core functionality shared. And this is essentially the contract here. This is what they mean by the contract. But it's a very generic contract because all these three classes are agreeing that they will have these three methods named exactly like this, and that they're not going to have any inputs, but moheight will return an integer, frequency will return an integer, and the invoice monthly will return a value of logic. So this is the contract that these classes are agreeing to. So when I'm in code and I see, oh, you've created an instance of the professional class, I know that it's going to have these three methods in it already. And I know that two of them are going to return integers and one of them is going to return a logic. So that's where you start seeing the utility of the interface, of ensuring this, driving this consistency where three separate classes all have this core functionality. Now, how they implement this core functionality, the throughput has to be written in each separate class. So each class, however it gets to moheight and spits out an integer, that's completely up to you when you're writing the code for this. So that's what seems weird about the interface. It's like a car, but it doesn't have the engine in it. So you have to put the engine inside of each of these methods. It doesn't come with the engine. It just tells you, I need the car to go 60 miles an hour and have four doors. This is saying, I need a higher interface in it. You need to tell me the height, how often, and bill me monthly. So it's setting the requirements. You're not just limited to these methods. You can then add additional methods. But at a minimum, the contract is you will have these three methods inside of your class. That's the contract. This has all been very abstract, and these are some notes. So let me go into some code, and we'll take a clearer look at this, hopefully. I have a separate example already up and running in the game. So I'm just going to go ahead and double click this. And I have the code already written for this. This is an interface here. We have our modules here. The methods that you write in your classes, they must have the override specifier. We're meeting these general requirements, but we're implementing it, each one in our own way. Here's how we create an interface. We come up with a name for it, then the colon equals, and then interface, and then the parentheses colon. And then here are our three methods: the moheight, the invoice monthly, and the frequency. So the moheight takes in a float, the invoice monthly takes in a value of logic, and the frequency takes in an integer. None of them return anything. So this is the contract right here. So the contract is, if I create a class and implement this interface. So this is what I do down here. I've created three classes. One's professional, one's student, and one is AI robot. I've created three separate classes, and by putting these parentheses and putting higher in there, I'm implementing this interface, which means that I am agreeing that I'm going to have these three methods inside my class, and that they're going to have the same inputs: a float, logic, and int, and that none of them are going to return a value. And if I try to tamper with this contract, if I try to say, well, I want to return an int with this function, I'm going to get a total error all over the place, because essentially I'm violating the contract. So I violated the contract, so I can't do that. Now what I write inside of here, in the body of the function, is completely up to me. And this can vary among the classes. So this is the throughput, the body, what I do with this value once I get in it, and it doesn't care. It just, down here, you can see we can create instances. So here's our creative class. So we've got a bunch going on here. So we've got our interface up here, and then we have our 3 classes that we've written. And I can add additional methods to each one of these. I've met the minimum requirements for the contract, so I'm good, and I can add additional methods to my class now if I want. I haven't added additional methods to these, but if I wanted to, there'd be no problem with me doing that. I just can't change what I've agreed to here. So down here, what we do is we create instances of our classes here. So I'm creating one called MyRobot, which is an instance of the ARobot class that implements the higher interface. And then I create one for MyProGardener and MyStudent. And then here, what we can do is we can call these methods now within these classes. So I can call reference MyProGardener, call the invoice monthly, and send true to that, right? And then it's going to print out whatever message that I need that applies in this particular case, right? Okay, so it finished loading up. So all this is going to do is print out 3 strings in the left corner for 2 seconds. It should. Yeah, see, billed monthly, received. So it wasn't really much to see there, but it did print out the strings that we called. So I wanted to give you an example from the verse code. So if we come in here and look at creative prop, this is a class. And here it's doing a couple things. It's inheriting from the creative object class here. And then it's implementing an interface here called invalidatable. And if I click here, you'll see invalidatable is an interface. It's actually implementing an interface called disposable, which is an interface. So as you can see in the verse digest itself, that interfaces can implement other interfaces. So that's what you've got here is invalidatable is an interface that's implementing the disposable interface. So you can see what a rabbit hole things can become. So one of the things that this can do, you'll notice what it says here. It says succeeds if this object has not been disposed of either via dispose or through an external system. So this is called is valid, right? And it's telling you that this is one of the methods that we can call upon if we implement the creative prop class. So when we implement the creative prop class, we're actually drawing upon here this interface here. Now notice this interface here just has one method inside of it called isValid, and it's implementing this disposable interface here. Creative prop is not only inheriting from the creative prop object class, it's implementing the invalidatable interface. So let's take a look at that, what this looks like. So what I have here is I've created a verse file, and I have a creative prop, and I have a prop manipulator, and they're both at editable. My prop manipulator has one method called damaged event, and it also has one called destroyed event. So when a prop is damaged, we subscribe to this check status method that I wrote, and here we're calling upon this is valid method. So this is actually, we are calling an interface here. So I'm checking the status. I'm going if my prop is valid, and it'll succeed if it's still there. So it'll print out this is valid. So while this is getting damaged and getting called, it's going to keep saying it's valid, but when it gets destroyed, then the prop is not valid and it's gone. So here we have it in the scene. I've got my verse device over here, and you see I paired it to a spooky doll I've got a prop manipulator over it. And so if I go into the code, you go back into the code here, and I come over to the spooky doll or the banana doll or whatever, and I hit it, you'll see I get a print string saying the prop is valid. And see, I keep whacking it. I can keep hitting it. And it's still valid. I have the points pretty high. So I'm still getting prop is valid, prop is valid, prop is valid. But then once I get to the very end, you'll see the message is going to change to prop is not valid. Bye-bye. So calling is valid is accessing a method that's within an interface. So that's where you'll see it in the code. I realize this was kind of a long video, but I really wanted to take a deeper dive into an interface. And so I hope you found this of some help.